Swayam Prabha. Digital India. Educated India.
Hello and welcome. I am Abhinav Dhal from the Indian Institute of Technology, Ropar. Friends, this is the lecture in the series of affective computing. Today, we will be discussing about how we can recognize emotions of a user by analyzing the voice. So, we will be fixating on the voice modality. So, the content which we will be covering in this lecture is as follows. First, I will introduce to you, give you some examples about why speech is an extremely important cue for us to understand the emotion of a user. Then, we will discuss several applications where speech and voice based affective computing are already being used. And then we will switch gears and we will talk about the first component which is required to create a voice based affective computing system, which is labeled datasets. And in this pursuit, we will also discuss the different attributes of the data and the conditions in which it has been recorded. Now, if you look at me, let's say I have to say a statement about how I am feeling today, and I say, well, today is a nice day and I am feeling contented. Now, let me look down a bit and I say, today is a wonderful day and I am feeling great. Now, in the first case, you could hear me and you could see my face very clearly. And in the second case, my face was partially visible, but you could hear me clearly. And I'm sure you can make out that in the first case, I was showing neutral expression. And in the second case, even though my face was facing downwards, not directly looking into the camera, I was sounding to be more positive, right? So, there was a more happy emotion which could be heard from my speech. So, this is one of the reasons why we are using voice as one of the primary modalities in affective computing. You talk to a friend, you understand their facial expressions, you look at the person's face, but in the parallel, you're also listening to what that person is speaking. So, you can actually tell how that person is feeling from their speech. And that is why we would be looking at different aspects of how voice can be used in this environment. So, here is an example. So, this is a video which I am going to play from audio-visual group affect dataset. So, let me play the video.
Protects. The other delivers protects. The other delivers.
So, if you notice in this case, the body language of the subjects here, that is trying to be a bit aggressive. So, this looks like a training video. But if you hear the voiceover, the explanation voice in this video, you can tell that there is no fight going on, there is no aggressive behavior, it is simply a training going on. And how are we able to find that? By simply looking at the tonality of the voice. If it was, let's say, actually a fight or some aggressive behavior shown by the subjects in the video, and the voice was also from one of the subjects, we would also hear a similar pattern which would tell us that, let's say, the subjects could be angry. But in this case, even though the body language, facial expression says that they are in an aggressive pose, but from the voice we can tell that this is actually a training video. So, the environment is actually neutral. Now, let's look at and hear another video. Now, in this case, the video has been blacked out. You can hear the audio and you can tell that there are several subjects in the audio video sample and the subjects are happy, right? How are we able to tell that? We can hear the laughter. Now, if I was to play the video, now this is the video which we had earlier blacked out. So, you can look at, of course, the facial expressions, but even without looking at the facial expressions and the gestures, just by hearing you can tell that the subject are happy. So, this gives us enough motivation to actually pursue voice as a primary modality in affective computing. Now, as I mentioned earlier, there are a large number of applications where speech of the user that is being analyzed to understand the affect. And friends, this is similar to how when we discussed in the last lecture about facial expression analysis, the several applications were there in health and in education. We find the similar use cases for voice based affect, but which are applicable in different circumstances. In scenarios where it could be non-trivial to have a camera look at the user. Of course, there is a privacy concern which comes with the camera as well. So, instead we can use microphones and we can analyze the spoken speech and the information which is there in the background. Now, the first and quite obvious application of voice in affective computing is understanding the man-machine interaction on a natural basis. What does that mean? Let's say there is a social robo. Now, the robo is greeting the user and the user has just entered into the room. The robo greets the user and the user replies back. Now, based on the voice of the user and the expression which is being conveyed by the user, the machine, which is the robo in this case, is able to understand the emotion of the user, and then the feedback to the user can be based on the emotional state. Let's say if the user is not so cheerful, so the robo reacts accordingly and then tries to understand with a question which could better make either the user more comfortable, relaxed, or the robo tries to investigate a bit so that it can have a conversation which is appropriate with respect to the emotion of the user. The second we see is in entertainment, particularly looking at computer movies. So, friends, in this case, we are talking about the aspect of indexing. Let's say you have a large repository of movies. Okay, so these are, let's say, a large repository. Now, the user wants to search. Let's say the user wants to search all those videos which are belonging to a happy event. Okay, you can think of it as a set of videos in your phone's gallery, and you want to fetch those videos which, let's say, are from events such as birthdays, which are generally cheerful, right? So, from this audio visual sample, we can analyze the audio, which would mean the spoken content by the subject and the background voices, could be music. So, we can analyze and get the emotion. Now, this emotion information, it can be stored as a metadata into this gallery. So, let us say the user searches for all the happy videos. We look through the metadata, which tells us that when we analyze the audio, these are the particular audio video samples, which based on their spoken content and the background voice or music sound cheerful. So, the same is then shown to the user. Now, moving on to another very important application here. Let me first clear the screen a bit. So, looking at the aspects of operator safety, let us say there is a driver and the driver is operating a complex heavy machinery. You can think of an environment, for example, in mining, where a driver is handling a big machinery which has several controls. What does that apply? Well, harsh working environment, a large number of controls of the machine, and the high cost of error. So, the driver would be required to be attentive, right? Now, you can clearly understand the state of the driver by listening to what they are speaking and how they are speaking. From the voice pattern, one could easily figure out things such as if the person is sounding tired, is not attentive, has negative emotion. So, if these attributes can be figured out, the machine, let us say the car or the mining machine, it can give a feedback to the user. An example feedback can be, please take a break, right? Before any accident happens, please take a break. Because when I analyzed your voice, I could figure out that you sounded tired, distracted, or an indication of some negative emotion, which can hamper the productivity and affect the safety of the user and of the people who are in this environment around the user. Now, friends, the other extremely important aspect of where we use this voice based affect is in the case of health and well-being. Now, an example of that, which is right now being experimented in a large number of academic and industrial labs, is looking at the mental health through the voice patterns. So, an example of that is, let us say we want to analyze data of patients and healthy controls who are in a study where the patients have been clinically diagnosed with unipolar depression. So, when we would observe the psychomotor retardation, which I briefly mentioned in the facial expression recognition based lecture as well, the changes in the speech in terms of, let us say, the frequency of words which are spoken, the intensity, the pitch, you could learn a machine learning model which can predict the intensity of depression. Similarly, from the same perspective of objective diagnostic tools which can assist clinicians, let us say there is a patient with ADHD. So, when a clinician or an expert is interacting with the patient, we can record the speech of the interaction, we can record the voices, and then we can analyze how the patient was responding to the expert, to the clinician, and what was the emotion which was elicited when a particular question was asked. That can give very vital, useful information to the clinician. Now, another aspect where voice-based affective computing is being used is for automatic translation systems. Now, in this case, a speaker would be, let's say, communicating between a party or translating, right? So, let me give you an example to understand this. Let's say we have speakers of language 1, group of people who are in a negotiation deal, trying to negotiate a deal with group of people who speak language 2, and both parties do not really understand each other's language. Now, here comes the translator. Could be a machine, could be a real person who is listening to group 1, translating to group 2, and vice versa. Now, along with the task of translation from language 1 to language 2 and vice versa, there is a very subtle yet extremely important information which the translator needs to convey. Since the scenario is about negotiation, let's say a deal is being cracked, the emotional aspect of what is the emotion which is conveyed when the speakers of language 1 are trying to make a point to the other team, that also needs to be conveyed. And based on this, simply by understanding the emotional and the behavioral part, one could indicate, one could understand if, let's say, the communication is clear and if the two parties are going in the direction as intended. You can think of it as an interrogation scenario as well. Let's say interrogator speaks another language and the person who is being interrogated speaks another language, right? So, how do we understand that in what is the direction of communication? Are they actually able to understand each other? And when the context of the communication has changed, all of a sudden a person, let's say, who was cooperating is now not cooperating but speaks another language. So, that is where we analyze the voice. When you analyze the voice, you can understand the emotion, and that is a very extremely useful cue in this kind of dyadic conversation or multi-party interaction. And of course, in this case, the same is applicable to the human-machine interaction as well across different languages. Friends, also another use case is mobile communication. So, let's say you are talking over a device, could be using a mobile phone. Now, from strictly privacy aware health and well-being perspective, can the device compute the emotional state of the user? And then, let's say after the call or communication is over, maybe in a subtle way suggest some feedback to the user to perhaps, let's say, calm down, or simply indicate that you have been using the device for n number of hours. This is actually quite long. You may like to take a break, right? Now, of course, in all these kind of passive analysis of the emotion of the user, the privacy aspect is extremely important. So, either that information is analyzed, used as is on the device, and the user is also aware that there is a feature like this on the device, or it could be something which is prescribed, suggested to the user by an expert. So, the confidentiality and privacy that need to be taken care of. Now, this is a very interesting aspect, friends. On one end, we were saying, well, when you use a camera to understand the facial expression of a person, there is a major concern with the privacy. Therefore, microphone could be a better sensor. So, analysis of voice could be a better medium. However, the same applies to your voice based analysis as well, because we can analyze the identity of the subject through the voice. And also, when you speak, there could be personal information. So, where the processing has to be done to understand the affect through voice? Is it on device of the user? Where is it stored? So, these are all very extremely important applications which come into the picture when we are talking about these applications. Now, let us discuss about some difficulties in understanding of the emotional state through voice. So, according to Borden and others, there are three major factors which are the challenges in understanding of the emotion through voice. The first is what is said. Now, this is about the information of the linguistic origin and depends on the way of pronunciation of words as representatives of the language. What did the person actually say, right? The content. For example, I am feeling happy today, right? So, the content, what is being spoken, the interpretation of this based on the pronunciation of the speaker, that could vary. If that varies, if there is any noise in the understanding of this content which is being spoken, then that can lead to noisy interpretation of the emotion as well. The second part, the second challenge is how it is said. How is a particular statement said? Now, this carries again paralinguist information which is related to the speaker's emotional state. An example is, let's say you were in discussion with a friend and you asked, okay, do you agree to what I am saying? The person replies in scenario 1, yes, I agree to what you are saying. In scenario 2, the person says, yes, I agree. Now, in these two examples, there is a difference, right? The difference in which how the same words were said. The difference was the emotion. Let's say the confidence in this particular example of how the person agreed to the other, if the person agreed or not, or was a bit hesitant. So, we have to understand how the content is being spoken, which would indicate the emotion of the speaker. Now, looking at the third challenge, third difficulty in understanding emotion from voice, which is who says it. Okay, so this means the cumulative information regarding the speaker's basic attributes and features. For example, the age, gender, and even body size. So, in this case, let's say a young individual saying, I am not feeling any pain, as an example, versus an individual, adult saying, I am not feeling any pain, right? A young individual versus an adult speaking the same content, I am not feeling any pain. Maybe the young individual is a bit hesitant. Maybe the adult who is speaking this is too cautious. So, what that means is the attributes, the characteristics of the speaker, which not only is based on just their age, gender and body type, but also their cultural context. So, in some cultures, it could be a bit frowned upon to express certain type of emotion in a particular context, right? So, that means if we want to understand the emotion through voice of a user from a particular culture or a particular age range, we need to equip our system, our affective computing system, with this meta information, so that the machine learning model then could be made aware during the training itself that there could be differences in the emotional state of the user based on their background, their cultures. So, this means to understand emotion, we need to be able to understand what is spoken. Okay. So, you can think of it as speech to text conversion. Then how it is said. A very trivial way to explain will be, you got the text, what was the duration in which the same was said? Were there any breaks? Were there any ums and repetition of the same words? So that would indicate how it is being said. And then the attributes of the speaker. So we would require all this information when we would be designing this voice-based affect computing system. Now, as we have discussed earlier when we were talking about facial expression analysis through cameras, the extremely important requirement for creating a system is access to data which has these examples which you could use to train a system, right? Now, when we are talking about voice-based affect, then there are three kind of databases, the three broad categories of databases which are existing, which have been proposed in the community. Now, the attributes of these databases is essentially based on how the emotion has been elicited. So, we will see what does that mean, and what is the context in which the participant of the database have been recorded. Okay. So, let us look at the category. So, the first is natural data. Okay. Now, this you can very easily link to facial expressions again. We are talking about spontaneous speech in this case. Spontaneous speech is what? You are, let us say, creating a group discussion, you give a topic to the participants and then they start discussing on that. Let us say they are not provided with much constraints, it is supposed to be a free form discussion, and during that discussion within the group participants, you record the data. Okay. So, that would be spontaneous replies, spontaneous questions, and within that we will have the emotion which is represented by a particular speaker. Now, other environments, scenarios where you could get this kind of spontaneous speech data which is reminiscent of, representative of natural environment, is for example also in call center conversations. Okay. So, in this case, let us say a customer calls in, there is a call center representative, conversation goes on, and if it is a real one, then that could give you spontaneous speech. Similarly, you could have cockpit recordings during abnormal conditions. Now, in this case what happens, right? Let us say there is an adverse condition, there is an abnormal condition. the pilot or the user, they would be communicating based on how they would generally communicate when they are under stress, and in that whole exercise we would get the emotional speech, right. Then also conversation between a patient and a doctor, and I already gave you an example, right, when we were talking about how voice could be used for affect computing in the case of health and well-being, right, a patient asking questions to so a patient replying to questions to doctors. A patient replying to the questions of the doctor, and in that case we would have these conversations about emotions. Same goes for these communication which could be happening in public places as well. Now the other category for the voice based data set, friends, is simulated or acted. Now in this case the speech utterances, the voice patterns, they are collected from experienced trained professional artists. So in this case you would have, let's say, actors who would be coming to a recording studio, and then they could be given a script or a topic to speak about, and that data would be recorded. Now there are several advantages when it comes to the simulated data. Advantages, well, it's relatively easier to collect as compared to natural data, since the speakers, they are already informed about the content or the theme which they are supposed to speak. They also have given an agreement. So as compared to your natural data, privacy could be better handled in this case, or I should say easier to handle. Now the issue of course is, when you're talking about simulated data, acted data, then not all examples which you are capturing in your data set could be the best examples of how the user behavior will be in the real world. Now the third category, friends, is elicited, emotion which is induced. So in this case an example of course is, let's say you show a stimuli, a video which contains positive or negative affect, and after the user has seen the video, you could ask them to answer certain questions about that video, and the assumption is that the stimuli would have elicited some emotion into the user, right, and that would be affected, represented, shown when the speaker, the user in the study, is answering questions. Now let's look at databases which are very actively used in the community. The first is the IBO database by Batliners and others. Now this contains the interaction between children and the IBO robo, contains 110 dialogues, and the emotion categories, the labels are anger, boredom, empathetic, helpless, ironic, and so forth. So the children are interacting with this robo. The robo is a cute, Sony Aibo dog robo. So the assumption here is that the participant would get a bit comfortable with the robo, and then emotion would be elicited within the participant, and we can have these labels, these emotion categories, labeled afterwards into the data which has been recorded during the interaction between the robo and the children. The other data set which is very commonly used is the Berlin database of emotional speech, which was proposed by Burkhardt and others in 2005. Now, this contains 10 subjects, and the data consists of 10 German sentences which are now recorded in different emotions. Notice this one is the acted one. Okay, so this is the acted type of data set wherein the content was already provided to the participants, actors, and they try to speak it in different emotions. So what does this mean is now the quality of emotions which are reflected are based on the content and the quality of acting by the participant. Now friends, the third data set is the Ryerson audio visual database of emotional speech and song. Now again, this is an acted data set, contains professional actors, and these actors were given the task of vocalizing two statements in North American accent. Now of course, again the cultural context is coming into the picture as well. This is also acted, and if you compare that with the first data set of the IBO data set, then this was more spontaneous. Okay, of course, you would understand that getting this type of interaction is non-trivial. So extremely important to be careful about the privacy and all the ethics approvals which are required to be taken. Now, in these kind of databases where you have actors, it is relatively easier to scale the database because you could hire actors and you can have multiple recording sessions and you can give different content as well. Now moving on to other databases. So friends, the next is the IIT KGP SESC dataset, which was proposed in 2009 by Kolagudi and others. Again, an active dataset, 10 professional artists. Now this is a non-English dataset. It's in an Indian language, Telugu. Now each artist participant here, they spoke 15 sentences trying to represent 8 basic emotions in one session. Another dataset is again from the same lab called the IIT KGP SEHC, again by Rao and Kolagudi and others, proposed in 11. Now in this case you again have 10 professional actors, but the recording is coming from radio jockeys, okay, so from All India Radio. So these are extremely good speakers, and the emotions are 8 categories, again acted. But if you have high quality actors, then the assumption is that we would be able to get emotional speech as directed during the creation of the data set. Now moving forward, friends, the number of utterances here, this is a fairly good size data set, 15 sentences, 8 emotions, and then 10 artists, and they were recorded in 10 sessions. So we have 12,000 samples which are available for the learning of an emotional speech analyzation system. Now, in the community, there are several projects going on. Now, they are looking at different aspects of affect and behavior. So, one such is the empathetic grant in the EU. So, there as well, there are these data set resources which are used for analysis of emotions in speech. Another extremely useful, very commonly used platform is the computational paralinguistic challenge platform by Schuler and Batliner. So this is actually hosted as part of a conference called InterSpeech. Now this is a very reputed conference in speech analysis. So in the compare benchmarking challenge, the organizers have been proposing every year different sub challenges which are related to speech analysis, and a large number are related to emotion analysis and different tasks and different settings in which we would like to understand the emotion of a user or a group of users. Now, there would be some acted and some spontaneous data sets which are available on this benchmarking platform. Now, moving on from the speech databases, let's say the databases have been collected, could be acted, could be spontaneous. The next task is to generate the annotations, the labels. Of course, before the recording is done, the design of the experiment would already consider the type of emotions which are expected to be annotated, generated from the data. So, one popularly used tool for annotation of speech is the Arduino tool. Now, here is a quick go through of how the labeling is done. Let us say friends, here is the waveform representation. The labeler would listen to the particular chunk, let us say this chunk, can re-listen, can move forward, backwards, and they also could have access to the transcript, what is being spoken during this time. So, what they can do is, they can then add the emotion which they interpret from this audio data point, and they can label different things such as the topic of the spoken text, and also things such as who is the speaker and the metadata. So, once they listen to the content, they generate the labels, then they can save and then they can move forward. Now, extremely important to have the right annotation tool, because you may be planning to create a large data set representing different settings. So, in that case, you would also have multiple labelers, right. So, if you have multiple labelers, the tool needs to be scalable. And as friends, we have already discussed in the facial expression recognition lectures as well. If you would have multiple labelers, you will have to look at things such as consistency for each labeler, how consistent they are in the labeling process with respect to the sanity of the labels. So, you would like the labels to be as less affected by things such as confirmation bias. So, after you have the database collected, annotated by multiple labelers, you may like to do the statistical analysis of the labels for the same samples where the labels are generated from multiple labelers, so that at the end we have one or multiple coherent labels for that data point. Now, let us look at some of the limitations, and this also is linked to the challenges in voice based affect analysis. What we have seen till now is that there is a limited work on non-English language based affect analysis. You already saw the IIT KGP datasets, which were around the Telugu language and then the Hindi language. There are a few German speaking datasets as well, Mandarin as well, but they are lesser in number, smaller in size as compared to English only based datasets. So, what that typically would mean is, let us say you have a system which is analyzing the emotion of a speaker speaking in English. You use that data set and then you train a system on that data set. Now, you would like to test it on other users who are speaking some other language. Now, this cross dataset performance across different languages, that is a big challenge right now in the community. Why is it a challenge? Because we've already seen the challenges which are there, the three challenges, what is being said, who said it, and how it was said. So these will vary across different languages. The other is limited number of speakers. So if you want to create emotion detection in a system based on voice which is supposed to work on a large number of users on a large scale, you would ideally like a data set where you can get a large number of users in the data set, so that we learn the variability which is there when we speak, right? Different people will speak differently, will have different styles of speaking and expressing emotions. Now, with respect to the data sets, of course, there is a limitation based on the number of speakers which you can have. There is a practicality limit. Let's say you wanted to create a spontaneous data set. So, if you try to increase the number of participants in the data set, there could be challenges such as getting the approvals, getting the approval from the participants themselves, and so forth. Now, on the same lines, friends, issue is there are limited natural databases, and I've already explained to you, right? Creating spontaneous data set is a challenge, because if the user is aware they are being recorded, that could add a small bias. The other is the privacy concern needs to be taken into picture. So the spontaneous conversations, if the proper ethics and the permissions have been taken or not, the ethics based considerations are there or not. So all that affects the number and size of the natural databases. Now, this is fairly new but extremely relevant. As of today, there is not a large amount of work on emotional speech synthesis. So friends, till now I have been talking about, you have a speech pattern, someone spoke, machine analyzed, we understood the emotion. But remember, we have been saying, right, affect sensing is the first part of affective computing, and then the feedback has to be there. So in the case of speech, we can have emotional synthesis done. So the user speaks to, interacts with the system understands the emotion of the user, and then the reply back, let's say that is also through speech, that can have emotion in it as well, right? Now, with respect to the progress in the synthetic data generation, of course, we have seen large strides in the visual domain data, face generation, facial movement generation, but comparatively, there is a bit less progress in the case of emotional speech, and that is due to, of course, the challenges which I have just mentioned above. So this, of course, is being worked upon in several labs across the globe, but that is currently a challenge. How to add emotion to the speech? Some examples you can check out, for example, from this link from developer.amazon.com. There are a few styles, few emotions which are added. But essentially the issue is as follows. Let's say I want to create a text to speech system which is emotion aware. So I could input into, let's say, this TTS, text to speech system, the text. This is the text from which I want to generate the speech, and let's say as a one hot vector the emotion as well. Now this will give me the emotional speech, but how do you scale across large number of speakers. Typically, high quality TTS systems are subject specific. You will have one subject's text to speech model. Of course, there are newer systems which are based on machine learning techniques such as zero shot learning or one shot, where you would require lesser amount of data for training. Or in zero shot, what you are saying is, well, I have the same text to speech system which has been trained for large number of speakers. Along with the text and emotion, I would also add the speech from a speaker for which I want the new speech to be generated based on this text input, right. So, that is the challenge. How do you scale your text to speech system across different speakers and have the emotion synthesized? The other, friends, extremely important aspect, which is the limitation currently, is cross-lingual emotion recognition. I have already given you an example when we are talking about the limited number of non-English language based emotion recognition works. So, you train on language 1 a system for detecting emotion, test it on language 2, generally a large performance drop is observed. But one thing to understand is, let us say for some languages, it is far more difficult to collect data, to create databases as compared to some other languages, right. Some languages are spoken more, there are a larger number of speakers. Other languages could be older languages, are spoken by less number of people. So, obviously, the creating data sets would be a challenge. Therefore, in the pursuit of cross-lingual emotion recognition, we would also like to have systems where, let us say, you train a system on language 1 which is very widely spoken, and the assumption is that you can actually create a large data set. Then can we learn systems on that data set and later borrow and do things such as domain adaptation, adapt from that, learn from that, borrow information and fine tune on another language where we have smaller data sets, so that now we can do emotion recognition on data from another smaller data set. Now, another challenge, limitation is, this is applicable to not just voice or speech, but other modalities as well. When you are looking at the explanation part of why, given a speech sample, the system said the person is feeling happy. If you use traditional machine learning systems, for example, your decision trees or support vector machines, it is a bit easier to understand why the system reached at a particular emotion, why the system predicted a certain emotion. However, speech based emotion through deep learning, so this is deep learning, friends, DL, deep learning based methods, even though it has the state of the art performance, even then the explanation part of why you reached at a certain consensus based on the perceived emotion through the speech of a user, that is still a very active area of research. So, we would like to understand why the system reached at a certain point with respect to the emotion of the user, because if you are using this information about emotion state of the user in, let us say, a serious application such as health and well-being, we would like to understand how the system reached at that consensus. So, friends, with this we reach the end of lecture 1 for the voice based emotion recognition, and we have seen why speech analysis is important, why is it useful for emotion recognition, and then what are the challenges in understanding of emotion from speech. From there, we moved on to the different characteristics of the databases, the data which is available for learning voice-based emotion recognition systems. And then we concluded with the limitations which are currently there in voice-based emotion recognition systems.